Okay folks, this is going to be a video on the desk organizer for AutoCAD 3D. The lecture will be a separate video, so that is rendering now, and I will post that. This is just on creating your first assignment in Module 1 for AutoCAD 3D. So if we click under Mod 1 Tasks, we go into Desk Organizer. This is the pencil box or the desk organizer that you're going to create, and you're not creating it in 2D. You're past that, so you know how to draw this orthographically. We're going to turn this into a 3D model. So let me do this. Put this over here. Put that over here, and let me bring AutoCAD here. Right. So it's a metric drawing, so I'm going to start with a new metric template. I don't tend to use the 3D template, so I'll just use ACAD ISO. If you already have a 3D metric template, maybe you made one in 105, then you can use that. But feel free to use the AutoCAD one for this purpose. I will leave it up to you guys to create your proper layers and stuff. I'm just going to bang this out. Well, I guess I guess I'll feel bad just drawing it on layer 0. So I'll at least create maybe an object layer. Did I spell that wrong? OBJECT. And we want that to be thick, right? So we'll go. I like 0.4 personally, and then I go with, instead of default, I go with 0.2 for my thin. It's not quite as thick as 0.5 in the default for my thin lines, which is 0.25. But I like that much better. Okay, so and let's right click and we'll put that over there. Now, folks, as we look at this pencil box, right now we're in the world coordinate system, right? We saw that in the lecture today. If I hold down the middle mouse button and I push in my I hold down Shift, I can rotate my view. So as I look at this, right, I have my front view, my right side view, and my top. Really, which view is going to give me the most bang for my buck? Well, if we draw this right profile and extrude it, well, the base of the pencil box would be done. I then just have to poke the holes in it, which would be drawn in the world coordinate system of the top view. So let's do this. I'm going to actually start. Let me go back to plan, and I'm just going to draw a rectangle, the profile size of the top here, and that would be 300 by 100. So I'll type at 300 comma 100, right? Enter. So that's the profile of this top view, and now we can put all the holes in here. And I'll start down here on the lower left, and I'll work counterclockwise around, or we'll see how it goes. But I need a rectangle, and that rectangle is going to be filleted. And the fillets all have a radius of 5. And the rectangle is going to be what? It is it over? Yep, so it's over 6 and it is up 6 from the corner. So what I'll do is I'll use the from-o snap. You could use temporary tracking if you wanted to, but I'll use the from-o snap and say from here. That just establishes the last point variable in our drawing, right? Then we can use at. And we can say, what, 6 comma 6? So over 6 and up 6. And now we could say at again, 92 comma, and how far up? 44, right? So we can use relative coordinates here. Now I'm using at, and that's all predicated on the fact that I have, right, dynamic input turned off, right? So if you don't see it, you can toggle the visibility of the button, and then you'll notice I have that button turned off. And I'm just going to get rid of it so I don't even see it. Okay, so there's 6 in between, so I could do CO for copy, and I could grab that, and I could bring that over. 92 plus 6, would that be 98? And I could do some more math, but I don't know if I could do that math, so I'm just going to bring this one over 98 too. There we go. Now I have those 3, right? All right, now let's keep going around. We now have the rectangle here on the top, so REC, that already has our fillets. I'll do from again. I'm going to say from here, right? That establishes my last point variable at -6, comma, -6, right? over 6 and down 6 from that point. And now I could say at, and what, negative, was that 196? And then negative 30. Oops, I don't know what I typed. At minus 196, comma, minus 30. I typed something. I don't know what it was. I could look, but I'll leave it alone. Give myself a little more space. Oh, I forgot the comma. I didn't put a comma in between. All right, and lastly, we need this slot. So let me say I want to circle from FRO. You don't need the M, and then I'll do at, and what, 24 comma minus 26, and that has a radius of, is that 18? I think it's 18. If not, make sure you make it what it's supposed to be. Hopefully, in my defense, the monitor is far away, and it's kind of small here in this view. You'll probably look at it and say, no, it's not. It's fine. Let's copy this. So CO. I can bring this over 50. Hit escape, L enter. I don't really need to go to tangent. It's just going to be the quadrants. I don't have quadrant as a running OSNAP, so let's turn that on so we can pop on quadrant. And from here to here, spacebar to get out, spacebar. Spacebar would have got me back in, but I fat fingered it. TR for trim, drag that. And now we have all of our shapes that we need to poke a hole through our part. Now, there's going to be a mistake when we do this, but let's make the mistake first. Let me just show you the mistake. I'm going to rotate my view, and eventually I'm going to want to extrude all of these so I can poke a hole in my pencil box. So I'm going to say extrude, and I'm going to grab all of those. I don't want the rectangle though, so I'll hold down Shift, and I'm going to extrude all of these up. And what you're going to notice is, you notice that the slot has a different pattern to it. Right? Why is that? Well, AutoCAD did that recently to let me know that each one of these is a solid, but when I extruded this, I ended up getting a bunch of surface models instead. And that would not help us for what we want to do. We would not be able to subtract these surfaces from our solid. And you can see they are just individual surfaces that we have. Now, why did that happen? Well, let's undo here. And it happened because these are all closed P-lines, or closed shapes, could be a region. Right? This is not. So these are individual, 2 lines and 2 arcs. So when I extruded that, I did not get a solid. So these have to be a single entity, and we can just use the join command to turn that into a closed P-line. Now if I extrude that, it would extrude to a solid, not surfaces. Okay. I'm glad that AutoCAD did that, because what would happen is otherwise you didn't know that you had extruded a non-closed P-line and got a bunch of surfaces till sometime later down the road. And at that point it might have been a pain to go back and fix it. They added that hatch, and now you know immediately what you've done, which is fantastic. All right, so we're good to go. Now we don't even really need this anymore, but I'm going to leave it here as a guide to draw my right side. So now I want to draw on the right side of my box, and we talked about this in lecture, but there's a couple of ways to do it, right? We could type what? UCS. We could rotate around the X 90 degrees, right? UCS, we could, UCS, we could rotate around the Y 90 degrees, and now we have a right rotation of the UCS. If I type UCS, enter, enter, I'm back to the world coordinate system, and you could also just go to visualize, and under the coordinates pull down, you could choose a right rotation of the UCS. Now, it's not physically sitting on the right, it's a right rotation. If I want it to be on the right, well, I could move it. I could type UCS if I wanted to, and just click, and then hit enter. Now it physically sits on the right side, although I didn't have to move it here, but I could. Might make life a little bit easier. Okay, so now we need to draw, right? I'm just going to use the P-line command so we get a P-line. I'm going to track straight up 26. Sorry about the pup. I'm going to come down. I'm going to come over. I'm going to track up, and I'm going to come up 76. And I'm going to come right down, and now I've got that closed shape. And I don't need this temporary rectangle anymore, although I could leave it there. So I could say EXT for extrude. And I could use that and then just, instead of having to type, well, I would have to type negative 300. If I type positive 300, I would extrude in the positive Z direction. So I would have to type negative 300, or I could just click right there. Now I want to get rid of that rectangle, but you'll notice the box is on top of the rectangle. This might be I don't use it too much in 2D, but it might be a good time to have selection cycling on when you're working in 3D. So if I turn on selection cycling, when I click, it's going to allow me to pick that P line instead and erase that. I don't need that. Okay, so now at this point, I'll just type UCS, enter, enter, put my UCS back into the world coordinate system. Now I'm going to extrude these and subtract, but if I do it right here, the holes will go all the way through my pencil box. I don't want that. These need to be up 6. So I'm going to type M for move. I'll grab each one of these features, just pick a point, start tracking straight up, come up 6. I'm going to type EXT for extrude, P for previous to select my previous selection set, and voila, I can extrude those up. Now I can type subtract. I'm going to pick the pencil box itself, enter, and I'm going to pick all of those shapes to subtract from the pencil box. If I type if I type SHA and then offer realistic or something, you can see we're looking pretty good here. Okay, now a couple of things. We're going to need filleted edges, and I'll do that last. In 2D, I would fillet all my edges last. In 3D, I fillet my edges last. All right, now we need to add some text. You don't have to do AutoCAD secrets. Every user knows, unless you want to. If you're in Dan's class, I would probably do that, right, since it's his book. But, you know, in my class, you can do whatever you want. You can put, you know, your cool pencil box, anything. So what we're going to need to do is, if I want to put text on this surface, I'm going to have to put my UCS here. Remember, in class, we did what? We typed UCS, and we used the 3-point option. So I'm going to click, and I'm going to click, and now I have my UCS on this surface. I'm going to shut that grid off. All right? Cool. All right, now if I want to save this, I could do UCS, S for save, and call this whatever you want, right? Call it maybe wedge face or pencil box face or something like that. But now that way I could always bring that UCS back if I wanted to, right? So if I'm in the world coordinate system and I need to draw on that wedge face, I could bring that wedge face back, right? All right, I'm going to type plan. And now I need some text. Right? So I'm going to come right over here. I'm going to type DT. And I'll just pick a size here. And type my pencil box. Now, this is text. I need to turn this into closed P lines so I could extrude them, just like I did the right side of the box, right? So I could extrude them, and then I could either subtract or union them to the box. Now, there's a command that will allow me to turn text into closed P lines, and it's txt-exp. That's an express tool, by the way, so it's a add-on list program that allows us to do this. All right. Cool. All right, now, not only did it do it, but you'll see, right, it made it a heck of a lot bigger, and it moved it way down here. That's okay. There's a way to avoid that, but then I wouldn't be able to talk about what I'm going to talk about. And what you'll notice is I now have a bunch of closed P lines that I could extrude. All right, let's move this mess back. And I'm going to move this right about there. All right, now, I need this height to be what? I'm just going to do DI for distance. And I'm just going to kind of click 2 points here. And it looks like, you know, maybe about, I don't know, 11 millimeters, 10 millimeters or so. I want it to fit, you know, right on this face right here, just like it does in the handout, right? So let's just say 10 millimeters. Right? All right, now, here's the problem. This is not text anymore, so I just can't go change the size. But what can I do? Can I do scale with the reference modifier? I sure can, right? So scale, pick a base point right here. R for reference, I'm going to click from here to here and say I want that to be 10 millimeters. And now I can type move. I'm going to pick a base point over here so I don't have any snapping problems when I get close. And I can just bring this, and I can put that right there. And it looks like 10 millimeters was a pretty good choice. Okay, so now I can either engrave this or emboss it. I can extrude it into the box and subtract it. I can extrude it away from the box and union it. We've already done subtract, so let's do EXT. I can do P for previous to select the previous selection set. And I want to come off the box some distance, I don't know, maybe, 3 millimeters or something. So let's go with 3. And now I can type UNION, union, and I can just pick everything, and I can union this all together. And now I have one entity with that, right? With that extruded text on that surface. All right, now the last thing I need to do, we need to lay it out, but I said I would lay it out in next week's lecture, so you can just kind of focus on drawing it for now. The last thing we just need to do is fillet the edges. So F for fillet. The radius for the fillets is 5. And unlike 2D, you're going to pick an edge in 3D. So I'm going to pick that edge right there. I'll hit enter. And now I can just pick all the edges and do it all at once. So I can pick that edge. I can pick that edge. And I can even grab that edge without rotating around. Or I could hold down Shift in the middle mouse button. And I could pick that edge right there. Hit enter. And voila. That looks perfect. Nice. ECS, enter, enter. And I am done, except for the layout. And again, we'll do that in class next week. All right, good luck.